Okay, so please read the OER textbook chapter section 13.3 for more detail. In the previous video, you see that the K equilibrium constant is the thermodynamic function that tells us about the relative stability between reactant and the product. Okay, so because K is the thermodynamic function, so K is going to be state function as well. Okay, so the state function means that it's going to depend only the final and initial state. It doesn't depend on the path taken. So that means we can use this idea that we see before in chapter 8, right, when we talk about the Hess's law, right, to apply in this topic as well, right? I'm going to relate the K value to the chemical reaction. Okay, so what do I mean by that? Okay, so let's take a look at one. Okay, so if you have reaction A to B, okay, so this is the Kc expression that you can write, right, product over reactant. Now, if you reverse the equation, okay, so because you reverse equation, you are going to end up invert the equilibrium constant as well, right? Because now A become product, B become reactant, you are going to invert that, right? So that means in this case, the relationship that you see here, right, is going to be when you reverse the equation, you will need to invert the equilibrium constant, right? So the new Kc is going to be 1 over the previous Kc. Now let's take a look at second one. Okay, so second one, if you have the same reaction again, A to B, okay, so Kc is going to be expressed the same way, okay, product over reactant. So in this case, if we multiply this reaction by a certain number, right? So let's say you are going to multiply this by X value. So now A and B have different coefficient now, okay? So remember this Kc, you are going to raise each of the species by the coefficient. So that means in this case, you are also going to include those factor into the new Kc as well. Okay, so the new Kc is going to be raised by the new coefficient. So that means in this case, right, the new Kc, right? So if you multiply the coefficient in the equation by a certain factor, you are going to raise the Keq, right, by the same factor as well to get the new Kc. All right, 3. Okay, so if you add two or more individual chemical equations, so what would happen? Okay, so let's say if I have A to B and I have B to C, and these are different Kc for each of these reaction. Okay, so if I add these two together, okay, so if I add A plus B go to B plus C, so I add these together, what do we do to Kc? Okay, so if you add these two together, you are going to see that the new Kc, right, is going to be the new product over the new reactant, right? In this case, if you think about this, right, the new product over new reactant, you see that B appear on both sides of the equation. Same thing here as well, B on top, B on the bottom. So you can actually cancel B in this case, right? So that means it's going to involve only with A and C. So that means, so the new Kc would be C over A, right? So to conclude this, if you add two or more individual chemical equation to obtain an overall equation, right, you are going to multiply corresponding equilibrium constant by each other to obtain the overall equilibrium constant. Okay, so you're not adding them, you multiply them. Okay, so you multiply them. And here's a summary of if you manipulate the reaction, right? So what would happen to the Kc, right? So when you flip the reaction, you will need to invert Kc, right? When you multiply by a factor, you will need to raise to that factor. And when you add the reaction together, you are going to multiply by the corresponding Kc. Okay, so we're going to use this and apply this into example 1. Okay, so example 1 is giving us a reaction with the Kc. Okay, it asking you to find out what Kc of the following reaction that are related to the top reaction. So what do we do? Okay, so first, you probably notice that the second reaction happened when you flip the first reaction, right? And also when you multiply the first reaction by 3. Right? So if you flip this and you multiply by 3, you are going to get this second reaction. So that means in this case, what you do to the equation, the top equation, we are going to relate that to Kc as well. Because the first equation, you flip it. Therefore, in this case, you are going to invert Kc. Okay, so that means in order to get the new Kc, you are going to invert it. Okay, not only that, not only you invert it, but you multiply everything by factor of 3. So therefore, you are going to raise everything to the factor of 3 as well. Okay, so that means the new value of Kc that related to this equation right here is going to come out equal to 1 over 3.8 times 10 to the 4th, and then everything raised to 3. Okay, so it's going to come out equal to 1.8 times 10 to negative 14. Now let's take a look at example 2. Okay, so example 2 give us several equations asking us to find out Kc for this one. Okay, so this is going to be similar to Hess's law that you learned in chapter 8, right? So you are given several equations, you need to manipulate them in order to get a certain value of the delta H, right? That's what you will learn in chapter 8. This one, we are going to relating of these, right, in order to find out the new KC. Okay, so what you will need to know is that you will need to manipulate this somehow to get into this desired equation. So according to chapter 8, we learned before, right, in order to find out a new equation, what you need to avoid is going to be the species that appear in more than one equation, right? Because it's going to make things complicated. So in this case, I'm going to avoid these two, right? Because those are, if you try to increase one or decrease the other, it just become too complicated. So in this case, if you're looking at this, right? So you're looking at hydrogen. Okay, so hydrogen appear on the second equation. Hydrogen is already on the reactant side, so that means that's good. Okay, so I don't have to do anything. Okay, so that's gonna stay the same. Now let's take a look at the top one. Okay, so the top one, remember, if you are going to manipulate anything, you need to rewrite even though it's the same reaction. Okay, so that way we know when you add them together, you can check your answer whether you get the right equation or not. Okay, so the second one is, if you think about this, right? So carbon dioxide, right? So it's the second species, and carbon dioxide is appear in the first equation, but it's on the opposite side. So that means in this case, you flip the reaction, right? So when you flip the reaction, carbon dioxide now is going to be part of the reactant, and the other part would be the product. Okay, so remember, according to the KC that we see earlier, right, when you flip the equation, you are going to end up, you need to invert the KC. So in this case, KC would be 1 over 490. Okay, now add these two together, right, because you need to add these two together. If you add these two together, you are able to cancel the cobalt oxide, right, and then cobalt solid. Okay, if you add this together, you are going to get exactly what we want, right, which is this desired product right here. Okay, so that means in this case, when you add the reaction, remember, according to the rule that we see, right, when you add something, when you add the reaction, you are going to multiply that KC together. So that means in this case, the KC of this equation right here is going to come from the multiplication of these two KC. Okay, because you add them together, so you multiply them. Okay, so the KC would come out equal to 0.14. All right, so again, so here's the summary of what you need to do when you manipulate the equation, right? And what would that happen to KC?